Welcome everyone. It's great to see you all. So welcome some of you back and welcome others for the first time to our KVR Digital Heritage series. This spring we have a new series, and this is the first session in that series devoted to historical newspapers in the digital age. These series are organized by KB and ULB, and it's really nice that we have this network function where we see so many returning and other sympathizers on this series. So we're going to talk about historical newspapers in digital age. Why? Because obviously newspapers are a hugely important source of historical research and historical knowledge. They contain so much information about visual documents, textual documents, places, organizations, etc. And they have been popular among historians for a very long time, and among other humanities scholars as well. There has been a massive digitization movement, as you all know, which have totally changed the way in which we look at historical newspapers. Whereas traditionally it was a very hard source to consult because it was a very time-consuming source. We had to manually peruse every newspaper. Today, on the other hand, we face more like an excessive data because there's so much digitized, and we need new methods, new ways of researching them. So this is why we organized this series, where we're going to look at 3 case studies of ways in which to research historical newspapers, including methods that look at OCR, at segmentation of articles, and NLP tools. The first seminar of today is the one hosted by Guillaume Bernard, and I will now pass the floor to Isabelle Grillemont, who will introduce Guillaume.
Many thanks, Brecht. So it is my great pleasure to introduce Guillaume Bernard, who is a postdoctoral researcher at the University of La Rochelle and is specialized in the analysis of historical documents, especially news and heritage documents. So many thanks, Guillaume, for accepting our invitation, and the floor is yours.
Sorry, could I just interrupt one last organizational word? The session will be recorded, so if you don't join it, please turn off your video. And for everyone,
can't hear you, Brecht.
Oh yeah, sorry. So
Lost you again.
So do you hear me now?
Yes.
Okay, sorry. So there will be questions at the end. Please turn off your sound in the video during the presentation, and please note that the session will be recorded. So if you don't want to appear in that, be sure to adapt your settings. Thank you very much.
My turn. Okay, thank you all for being here. I'm Guillaume Bernard, as it has been said. I'm a postdoctoral researcher at the University of La Rochelle, and I'm going to introduce you my research project, my thesis research project, which was focusing on detecting and tracking the events mentioned in historical documents. So I'm working in the L3Z laboratory, which is located in the University of La Rochelle, France. And we have a long history of research on document analysis, and it has been done since its creation. So we have, among other things, a strong expertise in automatic language processing and computer vision, whose purposes are document-oriented. We work with documents of different natures and different objectives for detection within official documents, analysis of structured and digitized documents, and analysis, of course, of historical documents for the humanities and social sciences. So my works fall within the latter framework. I'm working on historical document analysis, and I focused on the historical press, and I'm now working on other historical manuscripts, which are census tables. So this work takes place in the context of the digitization of historical heritage resources, so press and legal documents or photographs, among others. These digitizations generate large collection of data, and digital tools provide some solutions to process and analyze them. So work of this type involves a variety of researchers in the humanities and social sciences, archival science, and computer science. Each has a specific role to play, and in the case of computer science, the problems are image processing and natural language processing techniques. So in language processing, work is being done on the detection of articles in press documents or on text mining, such as the extraction of context from text. So one of the problems of a historical analysis is the constitution of a documentary corpora that will be used to analyze historical issues. This corpora can be constituted by visiting historical archives or all collections of documents, or by accessing digital libraries, such as the Gallica platform we have in the French National Library, which give access to hundreds of thousands of digitized newspapers. So we propose here to look at a particular way of constituting this corpora, the search by events mentioned in the text. This is, for example, to provide a way to search for all the press articles published at a certain period and related to this, for example, anarchist plot, which is mentioned in these newspaper pages in 1893. So, my work was entitled Detection and Tracking of Events in Historical Press Articles, and we will describe all the terms of this title to properly understand the concepts associated with it, and of course to understand the scientific issues which are involved. So we'll begin by defining the notion of event that we'll have briefly discussed. So digital libraries are, as you all know, generally managed by libraries around the world. So in France we have Gallica, the Gallica Digital Library, that provides access to the digitizations of the BNF, and abroad, well, in the United States, for example, we've got an equivalent platform which is provided by the Library of Congress. So you probably have one in KBR, I suppose, and there are probably other ones in other libraries all around the world. So these digital archives are the subject of scientific studies, such as, for instance, big French project, which was Numa Press or Oceanic Exchange, you may know. One was focusing on the French press and the other one on international press. In order to track the events that were mentioned in historical documents, they use a technique that consisted of detecting portions of text in the documents, paraphrases that were taken up from one newspaper to another, so it's a way to understand how it propagates the information in the documents. It's a sign of transmission of information. So the semantic level of this kind of work is very low. And another project, the Newseye project, which was a European project that started back in 2018, opens up new possibilities as it integrates an event detection task applied to specific themes, such as the mention, for example, of the mention of women's rights in the press. So, however, event analysis and detection requires a definition of this notion, the notion of event, which is ambiguous because it is defined differently depending on the research context, and particularly in history and computer science, because in computer science we've got a very strange definition of what we consider as an event. So, if we focus on the state of the art in computer science and in digital humanities and try to merge things together, we may consider that an event is something that happens at a specific place and at a specific time. As it's indicated in the diagram, it is an action encoded in time and space. It is itself caused by other actions, and it will in turn cause other actions in an endless cycle. So events are also specific occurrences. So they are type, which is shown in blue on the diagram, and they involve participants, which can be people, places, geopolitical entities, for example. The event is therefore linked to a number of participants, and they are all characterized by the role they play for the event. So, for instance, we can have for an assassination, we have the perpetrator of the assassination. So finally, other definitions restrict the notion of event to, well, in our field in computer science, to action of societal importance, such as military conflict or natural disasters. So to summarize the definition we have adopted here in this work, an event is a type of action which is caused by other actions and has its own consequences. The event evolves in its own spatial temporal framework, and it involves participants, people, places, etc. So we've just defined the first concept in the title of this work, the notion of event in simple words. The second element to which we'll turn our attention is the historical press documents. So first activity was rich in the 19th century with national newspapers appearing. I will take the example of France because my work focuses on French newspapers, but we've got the first newspaper that was published in French, which was Le Figaro back in 1826, or we had also more local or committed newspapers that appeared in the end of the century. This period is considered in France as the golden age of the press because of laws liberalizing the press in 1880s in France, and this brought profound challenges to the news actually, and professionalized the profession of journalist. So this golden age came to an end in the early 1920s with the advent of wireless transmissions and the democratization of radio. So in order to be processed by a computer, it is necessary to transform any page that you have, that you can manipulate, that is physical, into digital data by a special acquisition process that starts with the scanner. So once the image is obtained, the articles are extracted and the text themselves. And all those steps have a consequence over the ability to track events or to analyze the historical documents. So the last step is probably the step that opens more challenges, is the one consisting of analyzing text in search of entities such as cities, people, events, or more, for example. So in the first instance, of course, we use a scanner to transfer the physical object, the newspaper page, to its digital representation, the image. Okay. So once the document is scanned, the process segments the pages into portions and identifies the articles. Here we are looking to extract complete articles that sometimes span several columns. In the figure on the right, you see that an article that starts in the first columns continues through column 2 and 3. So this is one of the problems one of the challenge of the segmentation. So to identify the problem with these tools, we zoom in the green area you have here, and if you apply a segmentation tool in this to this area only, you will find that it extracts small portions of text and not the whole article. So we call these portions text segments because they do not represent text articles. So since a segment does not contain a complete article, this phenomenon is called over-segmentation. And it implies that articles are very divided into small portions. So this is the first problem we face in this kind of problem. We have another problem, because if we apply OCR on each of these segments, the character recognition will probably add some errors, because sometimes you've got errors in the documents themselves. You've got holes in the paper, like the image on top, or sometimes the digitization process add errors and you've got blur on the image, on the digitized image. So on the previously extracted text sections, if we want to extract the previously shown text section, we can use OCR to extract the text, and the transcription, of course, may contain errors, which we can evaluate using CER, character error rate, or word error rate, in order to evaluate the efficiency of these tools. And so we can also run semantic enrichment in these portions of text in order to extract elements in sentences like grammatical turns, event mentions, named entities, etc. So here you've got an example. The software extracted Miss Madame Clovis, which is actually the person and which has the grammatical role subject in the sentence. So far I have mentioned the problems of form, but questions of substance remain. Indeed, the journalistic style has evolved and has changed since the 1850s. So places' names have also changed, and some, such as Kingdom of Prussia, no longer exist today, but can still be mentioned in historical articles, of course. So the question of time is also central, because if you see on the telegrams published on the right, they are actually published the 24th of April 1853, but some refer to actions that took place days earlier, like 1 or 2 days earlier. This is one of the fundamental differences with the speed of propagation we experience today with the web. So with the web, it's almost instant, but with historical press, we've got to take time into account in the propagation of information. Okay, so to conclude on these notions, we face digitization problems that are related to the acquisition processes, and it is necessary to be attentive to both substantive and formal issues. So the data manipulated in this work present problems of segmentation, the problems you actually, I suppose, face, and text recognition and enrichment that might be incomplete or erroneous. So the second term of our problematic is the detection and tracking. So we're focusing on historical document, but what is meant by detecting and tracking events in text? Actually, to specify the problem, detecting and tracking events in historical press means connecting together previously extracted text segments according to whether or not they describe and relate the same event. So once the documents are grouped by events, we can apply tools for plagiarism detection, propaganda detection, source identification in order to enrich our knowledge about events. So in this work, we focus only on the task of grouping articles to whether or not they deal with the same events. This is the central part of the diagram. So on these groupings, we perform a quantitative evaluation by the proportion of documents which are actually correctly grouped together with standard metrics we use in computer science and in information retrieval, which are precision, recall, and harmonic mean. So it's not a qualitative evaluation, and this is one of the problems we have in information retrieval studies applied on historical or not applied on real life topics or real life research. So to assess the quality of these groupings, we need data. Data is indeed that, well, we need some data that associate a set of articles with an event identifier. This is the only way we have to verify that the algorithms we develop correctly associate documents mentioning the same events. So if we consider that we have press articles like those shown on the right, they all have in common that they mention the same entity, Elizabeth II. Yet the three articles deal with two separate events, as the list column shows. So we have different events. So the first two are associated to the same event, which is the death of Elizabeth II. But the third item is about a different event, the Queen's reception by the new Prime Minister distress. So we are therefore looking for datasets in which the documents all have event identifiers as an annotation. So articles identified by the same number describe the same event. So this is really the main problem we have to track events in historical documents, is that we don't have historical documents annotated with events. This is a very challenging issue. So the press data sets that fit our purpose are available in the scientific literature. We have some data sets, but the problem of these data sets is that they are based on web news articles and they are not historical articles. So we have some data sets like Europe Media Monitor, multi-source linking that actually focused on the same task, detecting and tracking events in documents, but they are not available. And so we have only one dataset that has been published recently, which is called Event Registry, which contains news articles and that is compatible with our definition and that we can use because it is also public, because it's another problem we have. is that we have only a few datasets that are available and shared by the community to the community. So the COVID-19 pandemic, well, emerged during the first months of this work, and it was a good thing. Well, for this work, it was a good thing because it produced, well, a lot of datasets were produced in order to identify fake news and to track fake news. So it was more to identify the different fake news that spread on social networks. But if they spread, we have an identifier for a fake news, and so we are able to track how a fake news is shared over social networks. So in these datasets, articles and messages are published and identified by the same event identifier. They report the same fake news or the same true news also. So we have considered that these short texts published on Twitter are very similar to telegrams. So it's a strong hypothesis. So they are similar to telegrams, so which were widely used to transmit information in the 19th and 20th century. So this is why we decided to use them, because we also wanted to track information that was reported in telegrams and written in the press. So the problem is that, as you probably understand, these are digital press articles extracted from the web, but they are not digitized historical press articles. So we have to operate in a context that is comparable to the old press. So we have to reproduce the specificities of historical press. We spoke about segmentation of the segmentation, and we spoke about OCR issues. So the main problem we have is that we have to synthesize the errors that we found in historical press by using recent press. So this is a very important drawback of all those studies, because as we don't have historical documents to work on, we have to synthesize things. So previously we have noted the differences with the recent press lie in the substance and form. So while the writing of the text is more complex to synthesize, we have altered the images to produce visually the defects of the digitization of historical documents. So we artificially degraded all the documents in the free datasets to cause errors in the text and to artificially generate segmentations. So this is it. We have the text. We first have the text, then we convert to image. We use degradation toolkit in order to degrade the image. We apply segmentation, OCR and segmentation. This is what you have below. We have the raw input text. We convert it to image. We use like a Time News Roman font, and then we degrade the image on the right. You've got holes in the image on the right. Then we can apply a segmentation algorithm, which is really a simple and naive process. Actually, each article is cut up evenly into 1 or 3 portions. This is the effect of the press, where the articles are divided according to the columns of the newspapers we are trying to reproduce here. So simple observation shows that the articles generally extend over these 2 or 3 columns and rarely more. So we are not concerned here with issues of positioning or typography, but simply with assessing the impact of dividing text into equal portions. So we are trying to evaluate the segmentation, the effect of segmentation. So we have 3 datasets that can actually become 12, because if we apply segmentation or not, or OCR or not, OCR degradation or not, we'll be able to evaluate the impact of OCR and over segmentation in the text. So, what's the purpose of detecting and tracking events in historical documents? Actually, the value depends on the audience. So for historical research, it will help understanding the propagation of information through newspapers and languages. This was the original goal. It was to detect actually if an event occurs somewhere in London, for instance. We know, because we have the knowledge of the networks of press agencies, that it is highly possible that the information spreads through Havas in Paris, then to Wolf in Berlin. And so it helps understanding the propagation of information. We have also a possible reduction of digital bias, because the effect of selecting elements randomly or by asking a search engine in digital libraries will probably introduce bias. But we actually do not pretend that our solution is not introduced bias, it introduces different bias actually. And for research in IT, it's what is important is the design of an event tracking algorithms, because these algorithms are actually used mainly used in finance, in monitoring finance changes and monitoring news for capitalist purpose actually, but not for historical documents, analysis, or social sciences. And we also want to identify the effects of degradations. So we developed two different strategies. The first is based on clustering, and the second is a search engine. So we propose two approaches, yes. The first contribution uses techniques of clustering. So in the first step, we have articles that are grouped together according to whether they report the same event. And in the second step, we use tools to describe the event themselves according to the content of the text. And the second contribution we propose aims at solving the problems of the first one. So we have designed a search engine to collect all the documents that report a given event. So we'll start by the approach by clustering, and in particular with the state of the art. Maybe you will find, and you will see some projects here now. So the topic detection and tracking project is considered as the precursor in this field. The groupings of articles were not at the level of events, as in our definition, but at the level of topics. This is a broader definition than our definition of events. It addressed multilingual aspects through machine translation, and documents were encoded using TF-IDF weightings. So it's a way to represent a statistical way to represent the words and sentences. We have another project, major project, which was called Europe Media Monitor, which was developed by, well, funded by the European Commission, and its goal was to monitor the newspapers in all the European Union languages. So documents were encoded using the same procedure, using TF-IDF, and enriched using EuroVoc, which actually provides definitions and alignments between different EU languages. More recently, in 2016, the Event Registry project was the source of great advances. It focused on multilingualism and proposes new techniques to carry out event tracking, and proposes new algorithms to track mentions based in particular on another algorithm, which is K-means in machine learning. So next, the year after, the NewsLens project proposed an interesting innovation for tracking events. And they used a community detection algorithm, which is the Louvain algorithm, to identify groups of articles dealing with the same event. So we can consider that text in the same community actually identify the same events. So another innovation in the management is the management of time management, because instead of simply comparing the dates between the publication dates between of documents can be sorted in chronological order and regularly divided into 7-day batches. So each of these batches is processed independently of the others, and we can see how an event evolves in time. So we have other projects published by other authors that actually provide the same ideas, and that use also a community detection algorithm and batch processing. So to summarize, in all cases, the assumption is that a press document reports an event. This is a strong assumption, but if it's a press article, we will consider that it reports an event. And that once encoded, the encoding is a digital representation of this event. So our problematic is focused on historical documents, and these algorithms and projects have only dealt with the recent and natively digital press, not the old digitized press. Moreover, algorithms are described and evaluated but the implementations are not shared, so they cannot be reused by the scientific communities, which would allow us to test our hypothesis. So we see in the diagram on the right the first steps to go from an uncategorized set of articles to groups reporting events. So we have first to vectorize documents, and then we apply algorithms to track and identify events. So if we start with the first step, the vectorization of documents, we use a very common NLP technique to vectorize documents, which is TF-IDF. It consists in weighting the extracted terms in the form of bag of words without taking into account the semantics. The originality that we use here is that we decided to encode the title, the body, and the title plus body. But inside title body and title plus body, we extracted the lemmas, the terms, and the named entities, and we encoded each using its own TF-IDF model. So if we have press articles, we encoded the entities of the title with the lemmas of the title, etc. So we have 9 features for press articles instead of only 1. So press articles are therefore encoded with 9 vectors, and tweets, as they do not have titles, are encoded with 3 vectors. It's a way to enrich the representation of articles and to ensure that we'll be able to group together documents that actually report the same event and differentiate the documents that actually report different events. But if we follow recent advances in natural language processing, we can also use other models to encode the documents. So maybe you've heard about transformers and transformer models that are mainly used, and probably the one that is used in ChatGPT. Actually, they provide a way to encode the documents and to densely encode the documents, and they offer good performance on semantic similarity and multilingual similarity. So these models have the advantage of taking semantics into account, which the weighting the TF-IDF weighting based on bag of unigrams do not do naturally. So here too, we have 3 vectors that encode press articles and only 1 for tweets. So the latter having only the body text as content. I mentioned before the problems of time that spread and the propagation of events in time, and there are 2 different ways to handle time: in batch processing or by applying a mathematical similarity function. So in batch processing, the documents are processed in blocks of 7 days successively, one after the other. In the other case, the dates are compared and the difference calculated. The difference is passed as a parameter to, for example, an exponential decay function. So the smaller the distance between the dates, the closer to 0 second, the higher the similarity and vice versa. So it's a way to handle time. So the results is that we have 4 vectorization for each of our selected datasets. So we have different scenarios to be compared for the experiments. So I will not take too much time to describe the algorithm, but we have an algorithm that actually takes into account the set of documents you have, and that will actually build clusters iteratively. So the main idea is that you've got a candidate document, and you will compare this candidate with all existing clusters in order to assign this document to an existing event. So once you found a cluster that is appropriate, so a cluster that actually represents the event, you will add the document into the cluster, and you will update the cluster with the new document. So it's the idea of building events iteratively. And for training, it's only a logistical regression and a manual threshold finding. So that's quite simple implementation. And the other algorithm is an unsupervised algorithm, which is based on k-means, and the time is represented using a 7-day sliding window. So we just split all the articles we have according to time. We run a k-means over it. So we use different methods in order to compute the value of k, because it's in a non-supervised algorithm. We actually don't know the number of events that are mentioned in the set of articles we have. It's not possible to determine this in advance. So we have retained 2 different solutions, and actually not giving the details, but we demonstrated that it's more pertinent to use the silhouette score to find the correct number of clusters. So we propose two different algorithms. One is supervised and requires a training step and is based on another existing algorithm. And one is non-supervised, does not require any training. And the most important part is that it does not require any linguistic resource. This is important because as we probably do not have labeled and annotated documents with events, we have a solution in the case we do not have yet annotated data. So it's based on k-means and other proposals by Newslands. So if we now focus on the effect of OCR and segmentation, well, these are raw results, but for the experimental results, we will first look at the decrease in the results of the two algorithms, and we only test the decreases induced by the errors of the OCR. So to do this, we carried out the experiments without degradation of the OCR and then with it, and we compared the two results. The plots and the histograms you see are from the comparison between these experiments. So here, for example, we see that the impact of the OCR degradation is very low because it only reduces the F1, the value of the F1 measured by a maximum of 2 points for the supervised algorithm and unsupervised algorithm. So the conclusion to this is that the impact of OCR degradation is very low in our context, but as a reminder, we do not have real historical documents, but we've got synthesized historical documents. So this is a conclusion. This is quite an interesting conclusion, but this is surely limited. So in these two cases, the impact of the errors introduced into the text by the OCR seems weak. But if we focus on the segmentation, the results are presented here. And actually, when the documents are segmented into two equal portions, the impact is strong, especially on dense vectors. The second vectorization technique we decided to use. It's around minus 12 points on average in this case, and it's weaker around minus 8 points for the encodings in TF-IDF. So depending on the context, the vectorization technique that is used has an impact on the ability to cluster the documents regarding the events. So if we segment in 3 portions, it's even worse, and the impact is even greater, and the level of degradation of the results increases. So the hypothesis that the segmentation distributes the element that describe the event is therefore true. The answers to the question what, who, where, and when that actually describe the events are divided into the multiple segments. So over-segmented documents divide the knowledge about the events and make it impossible to group the documents correctly. So in this section, we presented two algorithms to track mentions of events in the articles that are degraded by a digitization process. The purpose of this work is to show the limits of these tools if they are used with historical documents. So we have shown that the impact of the errors by the OCR is very limited compared to the impact of the segmentations. But this method has a drawback. It's not very usable in practice because it requires significant computational and linguistic resources. So this is why we decided to focus on a different approach. And it's the second contribution of this work. We aim at solving the same scientific question, but with a special focus on the reduction of the need for linguistic and computational resources. And we'll now discuss the use of a search engine to collect the set of documents that report a given event. So the principle of the idea is very simple. We search press article based on events, and therefore on their description, the description of events. So this is a method already implemented in some digital libraries where documents are searched by filtering press articles, dates, and then searching for named entities. These search engines generally operate as a black box, and the evaluation of the results is quite complex. So the knowledge of the event is provided by the user, generally a scientist. So on the other end, and more recently, we have some work from archival QA, which is based on a search engine architecture to answer contextual questions about events mentioned in the press. So what, who, when, etc. So the authors search for documents based on queries that they forged using short descriptions of events. But we don't have description of events. So to summarize, the process is always the same. We filter documents, we sort the results by order of relevance, and then we have the documents that speak about the event. But all of this is based on the same concept, the query. So the fundamental question we pose here in this section is how to forge this query so that it returns documents mentioning events. So we use the previous definition of event to characterize them. So as a reminder, it's an action encoded in time and space and which involves the participants. So to represent these events, we can use generalist public knowledge bases such as Wikidata or Wikipedia that actually describe events. So to forge a query, it is necessary to describe these events and represent them. The first step of this representation process consists in extracting information from Wikidata. It's the knowledge base of Wikipedia. It's a generalist ontology in which two types of event coexist, those with or without premises. It's actually those that are announced beforehand in the press, such as a concert or a ceremony. So the figure on the left shows a hierarchy of events. At the base is an earthquake, which is, of course, a natural disaster, itself a disaster, and then an event. So with Wikidata, we extract the basic knowledge about the event, places, dates, participants, but however, the information is often missing, as shown in the figure on the right. Only 6% of all the events we have are associated with a participant of type person. And even more damaging, only half of the events have a temporal and spatial anchor. So we have a definition that actually says an event is an action encoded in time and space, but we are missing this information. So this is why we decided to remedy this problem to explore the Wikipedia pages of the events. It actually enriches the representation of events. For each event on Wikipedia, we explore the summaries of the Wikipedia pages to describe the events. And as you have probably seen, the hyperlinks in these pages lead to other pages and other concepts. And so by exploring these links, we enrich the initial representation of the event with, for instance, places, geopolitical entities, dates, time, people, etc. And we extract this, and so we enrich the representation of events. So the representation of events we propose here is a vector of properties identified by the concept identifiers on Wikipedia and not written in a particular target language. So an event is described by generic properties linked to the definition of an event, a type, a place, a time. And on the left, we have represented the concept association, which, in addition to these three generic properties, propose two specific ones, the target and the association. On the right, we see these properties once the language agnostic representation has been completed. So entities are connected to concept, abstract concepts. For example, the identifier WDQ656 corresponds to St. Petersburg, the location of this event. Okay. And to finally represent the events, it is necessary to transit from this agnostic representation to a textual representation in a target language. So Wikipedia allows us by providing a list of alternative names for each entity. Here, the entity Felix Yusupov is written in several languages, and all of which are likely to be used in the press, and thus all of which are necessary to describe the event. In the end, we have two different kind of categories, two different kind of languages. We have those used to describe the event, to obtain the knowledge about the events, and those used to export the event and to build the query. So in the figure on the left, you can see that in our example, the assassination of Rasputin this event is described in Spanish and French. On the right, the event is exported in Italian, although no data in this language was analyzed. So by analyzing only 5 languages, because we decided to focus on only 5 languages to reduce the computational cost, we actually decided to use French, English, German, Spanish, and Italian. Yeah, probably Italian, because they are the biggest Wikipedia editions are in these languages. Actually, we have a problem, because we miss smaller editions of Wikipedia written in Mandarin, Arabic, and many other languages. So to overcome this problem, we analyzed whether using vernacular languages improves the description of events. So the conclusion of this work is that in addition to the main languages on Wikipedia, you have to focus on vernacular languages, because you have some events that are reported in Wikipedia in Turkish, for instance, that do not exist in English. And maybe if the events occur in Turkey, it will be well described in this language. So an event is matched by a query that is sent to the search engine, which in turn returns the document associated with these events. So for evaluation, we just decided to annotate the documents with the Wikipedia and Wikidata identifier, and then we were able to evaluate the retrieval process. So we have actually developed a search engine. So the first step is a researcher, a user that wants to have information about a specific event, and will use a tool to describe the event, which is it's in orange, and this description is given to a tool that generates queries, and then we use a database that we interrogate with the query, and it outputs documents. So on the left, we have the event we want to search for, and then on the right, we have the documents we have. So for the evaluation, of course, we used 81 events we annotated, and the goal was to evaluate the results automatically. I'm not going to spend too much time on evaluation, but actually evaluation was a bit complicated. We had to find other metrics that differ from information retrieval metrics, and we decided to use a metric which was maximal F1, because if you remember, we say that the search engine actually outputs a sorted list of documents, and we consider that the knowledge belongs to the researcher, because the researcher knows when the document is no longer pertinent regarding the query. So you've got, let's say you are looking for documents for the assassination of Rasputin, and you know when the document is pertinent or not, and when you stop at some point, and when you stop, it's when you consider that this is no longer pertinent. So this is what we've done with maximal F1. We try to reproduce the expert knowledge in this field. And then we developed another metric, but that's not that much important. So we compared the same way the impact of OCR degradation and segmentation, and we have the same conclusion. First, the search engine overall performance is quite good. It works at an average of 60% in our metrics. So it is interesting because it outputs instant results, and it is no training is necessary. So this is really usable in practice. And so, as before, the impact of OCR degradation is limited, less limited, but limited. And if we focus on segmentations, we have actually the same problems. We see that when it's segmentation in 2 parts, the impact is very important, and in 3 parts, it's even more important. So as a conclusion, we actually, in this section, presented an event search engine for post documents, and we've shown the impact of degradations caused by OCR and segmentation on its efficiency. The errors introduced by the degradation of the OCR have a low impact compared to segmentation. So this solution has the advantage of being relatively resource efficient. We have restricted the architectures used so that it responds in a constrained time in our datasets. So this is relatively fast with a few seconds per event. And it makes the solution usable in practice for the target audience and the target public, researchers actually. Nevertheless, it must be acknowledged that this solution gives less good results than clustering techniques we presented previously, but it puts the researcher back in the art of detection and helps without replacing him or her, the researcher, in the constitution of the corpus. This is what makes more valuable. So we've just seen two contributions, detection and tracking of evidence in historical documents. So it's possible to use clustering approaches or to use a search engine. So we decided to focus on specific constraints to be resource efficient and to show implementations of data. So we can now conclude. So first, we've published event mention tracking algorithms. They are inspired and adapted from the state of the art. And we also share the training implementations because this is often something that miss the actual implementation of training processes. And we propose a new approach, which is based on an event search engine, which is more in line with real use cases. In a second step, we've shown in a preliminary work that the image degradation have a different impact on these tools, but we have only synthesized this data and we've not taken into account the background, actually the content of the text to see how it behaves. So we've produced an analysis of suitable datasets for event monitoring, and we also share them. So we decided to share the datasets produced in this work also with the intermediary data in order to facilitate both the reproducibility of the experiment and the iterative construction. So we share the datasets on the European platform Zenodo, and all the code produced is also released under free software license, the GPL-v3, and archived on Software Heritage, which is an international project for the conservation of source code. So actually all the resources and the algorithms are public, and you can use them without asking for any authorization. So the outlook opened in this work are both medium and long term. So in the medium term, the production of these algorithms will provide the tool for the constitution of corpora for scientists in social sciences and humanities. We help to solve the problematic initially formulated to assist without replacing researchers in social sciences with the constitution of their corpora. And we've seen the priority for improving the reliability of the algorithms must focus on improving article segmentation. Actually, the work has to be done on article segmentation. And well, I do not state that we don't have to focus on OCR recognition, but the degradation is mainly caused by segmentation. So this is what we have to focus on. So work of this type has been carried out in the French NewsEye project with the aim of improving the extraction of complete articles and reducing over-segmentation. And this is a topic we're working on in our laboratory. So in the medium term, this work published, well, we published the implementation so you can reuse them. And in the longer term, it is also the opportunity to build up real corpora of historical documents to evaluate the results on real historical documents. So the tools developed would help to make such annotation campaigns possible because it will be possible to pre-filter documents mentioning events. And while it would have been impossible before to annotate historical documents at the beginning of this work, it is now possible and undeniable that this work is part of the solution to actually create annotated datasets and then test new algorithms and then improve the datasets and then in an iterative way to actually find a solution to be able to track events in real historical documents. And this was my conclusion. I might have been too long.
Thank you so much, Guillaume, for this super interesting presentation and very relevant to what we're doing here at KBR, and I'm sure in many other cultural institutions. So it's now time for questions. So please, if you have any question, you can just raise your hand or write it in the chat.
Maybe to wait.
No, you go ahead.
I wanted to ask you something about the definition of event. It seems that you include only, if I can say, even described in the corpora of text, but do you also, do you think to include events that are not only described but performed by the text? I think, for example, in old newspapers, there are lots of criticism of the theater piece, of a book, of whatever, and the text itself is an action of criticizing the book, but there are no description of the fact that it is an event. And I wonder if you think, because otherwise, often in a critique of a book, they don't describe, well, they summarize the plot, but otherwise they don't describe a certain kind of event, a certain time and place, because the event is the critiques.
Yeah. Actually, we faced an issue at the beginning of this work because the definition of events is very complicated. Actually, that's it. In biology, they have a definition of event that is very different from social sciences, and maybe in social sciences, you, depending on the field you are working on, have different definitions of events. We had everlasting debates, even in my lab, about what was an event, and I decided to focus, I maybe focused 6 months on the definition of events. So it was a bit long, but to answer the question is no. We decided to, well, actually an event in this context is what I am trying to find the slide, but okay, I found it. An event in this context is, yes, something that happens at a specific place and time, and we decided to focus on what we call real-world events. So it's a happening caused by external factors or internal factors, but something that happens. And well, I understand that a journalist that writes something about another thing,
it is something that happens,
is an event, but this is not the kind of event we decided to retain, because it actually led to other problems regarding the events. So we decided to focus on actually undeniable events, and there is no discussion about, okay, so a earthquake, is it an event or not? But you will find people that say, okay, but someone who is writing something about something, it is not an event. You will find people, and there will be a debate. But if someone says, okay, the assassination of Archduke Ferdinand last century, is it really an event? Yes, it is. It is, and without any doubt, it is an event. So this is why we decided to focus on this very particular definition of event. Otherwise, it would be impossible to do anything. But this is a limitation, yes.
But it's good to know that it is taken into account. It is not like, oh, we don't know.
No, it actually, it's been a 6-month work to identify what is an event, and this was a philosophical question.
It is a philosophical question.
It is a philosophical question, and actually in my lab we had the discussion of, okay, Guillaume, you're thinking about philosophy and not IT, yes, but this is a philosophical
because
question.
you, in your definition, you encompass actions. And
yes.
In philosophy of action, they separate completely
yes.
events and actions.
Yes, and there are many papers that have been published on the analysis of events, the algebra of events, because people wanted to represent events as algebraic connections. So there is, the root is in philosophy, and well, the people in IT history, etc., decided to adapt the definitions. But this definition is more precise than many definitions we find in IT research project, because mainly people who are working on event tracking say an event is something that happens.
And you have the place, the time, and the participants.
Actually, what I found is that they often do not, well, they say the definition is something that happens, and that's it, but actually they always take into account time, place, participants, but they forget to mention it. So this is so obvious that they forget to mention it, but actually it's not obvious at all.
Thank you so much. Is there any other questions, maybe from one of our online viewers?
I have a question. I just have, it was a really nice presentation. Thank you so much. As part of the Data KBR project at KBR, we are working on identifying events in historical newspapers, but we're taking a qualitative approach, which is we're identifying protests in a specific year. And I just think that it would be really interesting to think about these we don't use a quantitative approach at all, but there for the protests, we think about it in like a really long period, which thinking about the quantitative models of identifying events based on 7 days. I think that I just, when I heard that, I thought, oh yeah, how long is this event? And I know it goes back to this definition also what you just responded to, but I think that that's a really interesting thing that yeah, perhaps you could say a bit more about how you chose the time window, or if you played around with that and what the effects were. So that's my first question, and if I have another one, but if others in the audience have them, I can wait.
Okay, well, to reformulate, the question is why, well, to simplify also, the question is why 7 days, yes? Okay, the choice of 7 days, well, at the beginning there was no clear explanation for why people decided to use 7 days, and probably most of the writers in the IT literature decided to use 7 days because it's a week, and that's the only explanation. But there are some people that decided to focus on finding a real number of days that is pertinent, and they finally came to the conclusion that 7 days is mainly used in the recent press. Actually, it's the lifespan of an event in the recent press. So this is what we often notice when something happens on Monday, and then next Monday we don't speak it. We don't speak about it because something replaced it. But well, there was a paper published on it which stated that when an event occurs on one day, it is described the first 2 days, for instance, and then you've got analysis, you've got a deeper analysis in the next days, and then at the end of the week it became editorials, and next week we don't speak anymore about the event. But at the beginning it was very intuitive, and people didn't have any idea why they used 7 days. But yes, some studied this and came to the conclusion that 7 days is a good window. But of course, it will be very different for historical press because the time does not span the same way in historical press. So in historical press, it will be necessary, I think, to study this also.
Following up on that, I was wondering if you thought about, the commemoration of big events. For example, if we take like 11 September, then every year there would be some articles that would address this again and again, and I guess maybe decreasingly, as the year advanced. So I was wondering then all of these would be considered separate events and not be retrieved, but they could still be retrieved, I imagine, with the search engine as part of the one event, right?
Yes, actually the search engine solves this problem because for recurring events that, well, maybe most recurring events are competitions in sports, because, for instance, each 4 years you've got the Olympic Games, and so if we're just looking for Olympic Games, you will find all the Olympic Games mentioned in documents. But if you add the notion of time, for instance, you will restrict. But for recurring events, the approach by machine learning does not work instantly, but with the representation we can actually run the algorithm once. We have clusters for a year, for instance, and you can run the algorithms on the clusters to cluster together the clusters that actually mention the same event. So you can use it you can use it to, let's say, cluster, like doing hierarchical clustering, like you cluster the documents into small clusters, then you group clusters together, and at the end you've got like global event, which does not describe anything, but you can probably, let's say you've got documents and you have clusters of, okay, it's a hockey competition, it's a football competition, and then you've got a ceremony, an inauguration, etc. And then on higher level, you've got sports events, and you've got political happenings, and blah 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 blah, and so you can cluster this way by applying successively the same algorithm again and again.
I see. Thank you so much. Do we have any more questions? So once again, feel free to just unmute yourself and ask it, or write it in the chat if you prefer to do so.
I have another question.
Yep.
About the second approach of using Wikidata to the list of named entities. I'm wondering how you consider historical place names that might not be in Wikidata, or even historical names.
Well, if the information is missing from Wikidata, it is missing from Wikidata. But the community in Wikidata took time, let's say, to indicate historical names for places using synonyms or other names used in the past. And we have, actually we can use, well, there are many techniques we use. For instance, if we consider the names in Algeria, we cannot consider only the names that are written in Arabic, because even if, well, because we have influence, and so as this is the official language, etc. But we also have to take into account past languages and past official languages, because actually in historical newspapers, for instance, places names are referred to colonial names, for instance, and not to the names that are used today. The best example is Bombay and Mumbai. And actually, if we are describing an event that occurred in 1850, we will ask Wikipedia to give the name that was used in 1850 and not the actual name, because it could probably not be used.
Here. I had one more question, which is, did I miss, but which OCR engine or tool did you use to OCR the historical newspapers? That was my last one.
We used Tesseract because it was freely available, and as we were in a process of sharing all the implementations to ensure reproducibility, we wanted to use something that was available for all.
Thank you. So I see that we have one question in the chat. So Stefan, I'm not sure if you want to unmute yourself, or the question seems to be about Wikidata and about the use of statements in Wikidata.
So the question is, why? What?
So apparently there is certain statements related to the same entity.
Yes, actually the statement is in the ontology, the description of a property. If you go to the link, you will see that the concept is associated to other concepts in the ontology. And so actually you can make queries for those who are used to manipulate ontologies, it will be obvious, but actually it's a way to represent knowledge, and it's a way to represent knowledge, and just a statement is a property that associates a concept with another one. So for instance, you have the concept you've shared in the chat, and if you ask for the title of this concept, you will have a text. But if you, for instance, go to the published in, you will see that it links to another concept. So you will be able to find information by inferences in the ontology, and this is a way to store and retrieve information. Yes, in the ontology. I don't know if I made myself clear, but yes.
Thank you. So, do we have other questions? In the meantime, I also have another one. You mentioned that when you use the TF-IDF, you enrich the data with entities.
Yep.
But when you use the transformer-based, you chose not to do that, I guess, because it's already encodes some semantic, information. But would you have considered to do it anyway, to add also entities to the transformer models?
Yes, but actually, as TF-IDF is a statistical approach, it was, well, I found it was pertinent to actually extract lemmas, tokens, and named entities. But in the context of a tool that, like a transformer, that actually encodes a sentence and in context, it became less pertinent to encode named entities alone, because we will actually have logic representing the named entities, and we will lose the context information, so they will not be added value compared to TF-IDF. So I just wanted to identify whether the computation of dense representation was actually improve the performances or not. And I have to add that TF-IDF weightings produced very, very large and sparse vectors because it's TF-IDF. But dense models actually produced vectors of less than 1,000 logit. So it was very, very faster when training and even when computing vectors. So well, and even the models I used are already outdated. because this field knows improvements like every month, so they are actually outdated approaches, and we'll have to retrain everything to test. And I expect the results to be higher now than it was before.
Thank you. Do we have a last question, maybe? Checking the chat. Or if anyone wants to raise their hands. If not, we just have to thank Guillaume once again for this very interesting and engaging and useful presentation. And we also let you know that this has been recorded, and therefore it will be uploaded on the KBR YouTube channel. And we also would like to advertise our next event. Brecht, if you can remind us.
I can remind you, we have 2 more events in this series. The 25th of May, Casper Berlin, Accessing Biases in Digitized Newspaper Collections, and the 15th of June, Maud Erdmann, Reliable Semantic Indexing of Historical Newspapers at Scale. Are we there yet? So this is just the start of our series. Thank you so much to our speaker, and for those of you that joined us today. If you haven't registered for those 2 future talks, you can do so on KBR's website. But before we leave, maybe turn our mics on to give a real round of applause to the speaker. Thank you.
Thank you.
Have a nice afternoon, all. Thank you for those at KBR.
If I may add something, feel free to send us a message if you want to, and just to speak about what we do in the L3 laboratory, because we're specializing in historical document analysis, and it will be our pleasure to help you analyzing your documents and maybe start projects and collaborating with people around the world who actually want to work with historical documents and read applications on historical documents.
Excellent. Very generous. I believe that was for everyone, but I will certainly be mailing you.
Thank you.
Thank you. Bye.